Welcome to Vertical City. I'm your host, Lennon Richardson. During each episode, I interview one of the world's top experts in architecture, urban design, engineering, or ecology so that we can better understand and develop solutions for sustainable living. Thank you for listening, and get ready to join us on another groundbreaking and uplifting episode. Brad Nemeth is the Vice President of Sustainability for Thyssenkrup Americas. Thyssenkrup is a multinational conglomerate corporation that specializes in the development and engineering of various materials and technologies, including elevator technology, which is the center of our discussion today. Brad has a core background in engineering, and he also has extensive experience in manufacturing, operations, supply chain, strategy, technology, and sustainability. He is a lead green associate and is responsible for strengthening Thyssenkrup Elevator's commitment to sustainability. Prior to joining Thyssenkrup, Brad provided sustainability consulting services to various companies, including USG Corporation, which became the first international industrial organization to publicly report its carbon footprint. In this interview, we discuss the breakthrough innovation known as Multi, a ropeless elevator system that is destined to change the way we construct our buildings and cities in the future. Visit verticalcity.org/podcast for complete show notes. Brad, thank you for joining me on the Vertical City podcast. Welcome.
Well, thank you very much, Lennon. Happy to and pleased to be able to talk about some of our new technologies and how this may be changing the urban landscape of the future.
Yeah, I agree. This is a very exciting conversation that we're about to dive into, and one that I've been looking forward to discussing for some period of time. That statement actually kind of leads me right into the first question I want to ask, which is, how long has this idea of a circulated elevator system been around, as far as you know?
Yeah, that's a great question. So from the elevator evolution, and its elevators have been around for about 160 years. The first circulating elevator was actually designed and called the cyclic back in the late 1800s.
Wow.
And in the early 1900s, so up to, say, 1940s, 1950s, these circulating elevators were called paternosters.
Okay.
And there's several of them still in the works in Europe. But the idea behind the circulating elevators in that original concept was that with the smaller elevators, and if they're on a continuous loop, you could actually move more people requiring less space in a building. Now, those original elevators are no longer, some of them are still in service, but the idea of that paternoster type of design, which didn't have any doors, by the way, elevator doors. You just had these moving lifts in the shaft that you would step onto or step off of, were fairly unsafe. So the idea of a cabled elevator really went back to the basics, and the paternoster was more of a niche market that we no longer provide to the market. So the cyclic elevator or circulating elevator has been there. The concept has been there for a long time. It's a matter of how do you do it efficiently, and that's where I think the Multi really hit the mark because now we could actually do one better because we could move cars in and out of a shaft depending on what the actual loads of the building are.
Okay, excellent. One quick follow-up question to those remarks. With this older circulated system, I'm not really familiar with it. Did it work sort of like a ski lift? That's what I'm picturing in my mind.
It did. So think of a vertical chain running vertically throughout your building, and these platforms at, say, 12-foot intervals, almost like a farm conveyor that you would move grain or wheat into a silo. It was really that kind of setup where you had these platforms moving, and with the chain, as the chain is moving up, You step on the platform, you move up and step off on a floor, and vice versa. You step on the downside and you move downward. It's, as I mentioned, there's no doors, so the safety standpoint was of great concern, and that's why you haven't seen any being built for the last 70 or 80 years.
So you would literally have to like jump on and jump off as it's moving?
Yes,
wow.
yes.
Okay.
Now, in reality, it's moving at about 0.3 meters per second. I think a human typically walks at around 0.2 meters per second. So it moved rather slow. It wasn't like an amusement ride at Disney, but it caused some anxiety if you're not accustomed to it.
Okay, yeah, I could totally understand. All right, so let's delve into this topic of the multi. Would you briefly just explain to our listeners who may not be aware of this technology that's coming out what it is, and then what are some of the significant benefits of this new technology?
Sure. So the multi is basically looking at a new way of moving people throughout a building. For 160 years, I mentioned, we always have moved people in a cabin, or what we call a car, the elevator car. And that has always been either powered by hydraulics or powered by a motor and the cab hung on cables. So the idea of that elevator system was perfected over a century, and we become very efficient in how we move people using ropes.
Okay.
Now, the issue with the standard elevator systems, in just a vertical standpoint, is that as you gain height in a building, you are no longer just moving a load of the elevator cab and the people inside of it. You're now having to compensate for all the weight of the steel cables, any of the traveling cables, and in the elevator business, traveling cables are your communication cables to the car, video, lighting, power, etc. So in a high-rise building, you could be moving or having to design an elevator system to lift, say, 20 to 30 tons versus just designing a system to lift the weight of the cabin and the occupants inside.
Okay.
So elevators, the traditional elevators, are still very efficient in the what we call low and mid-rise markets, but as buildings continue to increase, the weight of that extra material now becomes a hindrance to how tall we can go. So the multi utilizes, or basically is designed to eliminate all cables, including the communication cables.
Oh, okay.
And it uses a series of linear motors. So the cabin is basically independent. So I mean independent because wirelessly we communicate with the cabin. We control the cabin wirelessly. And we use higher technology to understand where the positioning of the elevator cab is within the building and within the shaft and with respect to other moving cabs. So the evolution of the elevator now has provided us with an opportunity to shrink the size of the cab, for instance. And I say shrink it because right now, especially in the U.S. and in many areas, the cab is designed not on how many people you're typically moving throughout the day. It's designed on your up-peak and down-peak capacities. So we typically design it for that morning rush when everybody comes in. So we're designing cabs in the U.S. to hold, say, 18 or 20 people. And in reality, during coffee breaks at 10 a.m. or 11 a.m., the elevator is maybe only has one or two people inside. So I say that it's over-designed. It's over-designed for purpose because of that peak time. How do we move people out of the lobby or back down to the lobby for those peak business times, typically 8 a.m., noon for lunch, and at the end of the day around 4 or 5 p.m. So the multi, with the ability to basically move cabins in and out of the shaft, allows us to, say, during those peak times, have a multitude of cabins available so that we can actually move people more efficiently and faster throughout the building. And then as we move into those slow times, we could pull cabs out of service and basically park them until we sense that there's another crowd or a group of people that need to be moved, and then we could cycle elevators back in and out. So that's the real big advantage of now having an elevator cab operating vertically right now without any cables attached to it. We have that flexibility to increase the number of cabs, decrease the number of cabs, and we went one step beyond with the multi and said, well, if we could move cabs in and out of the shaft, why can't we move cabs horizontally or diagonally or any direction that we have a internal shaft set up, because now it's all depending on how the linear magnetic motors are positioned and what direction we want to go. So we have that now, that flexibility that we can give to the architects to, one, I think the biggest benefit is that we can now design shafts in relation to square footage available for occupancy. So, and what I mean by that is if you go into a typical building, there may be 4 elevators or a bank of 8 elevators. 1, 2, or 3 of those elevators are rarely being used, and that's because we designed that system for that peak load where we have a lot of people that we need to move. So we could now start looking at minimizing the number of shafts that we need in the building, because we could now move cars in and out of the shaft to accommodate for those loads. So that allows architects to give space back to the building owner and allows us to have more, I guess, if you're a building management owner, more space to rent out, or in residential, maybe add 1 more room or a couple more rooms per floor.
That's really excellent.
Yeah, so that's, from a benefit, from a space standpoint, that's probably the largest and most important thing. The other things to consider that I think most of us don't realize is as buildings get taller and taller, typically the top of the building, the floor space gets minimized from a design standpoint. And so an elevator shaft or number of shafts could literally take up 15 to 20% of floor space in those upper sections. So with the multi being able to minimize the shaft requirements and even look at reducing the cabin size, now starts making the rentable space on high-rise buildings more profitable for business owners.
That's excellent. All right, so I have 2 quick follow-up questions for you regarding those statements.
Sure.
First, how big are the cabs that you would be designing?
Well, right now, we have prototypes built, and they're 1/3 of actual size.
Oh, okay.
We are building and installing full-size cabs in our new test tower in Rottweil, Germany, just outside of Stuttgart. And in those, we're designing and building and installing full-size cabs. Now, the cab dimensions themselves is dependent on elevator codes and ADA requirements.
How many people can they hold?
Right now we're looking at the typical design of a European type of lift. So initially we're looking at 5 to 7 people.
Okay.
However, from a technology standpoint, obviously that's flexible. We can go up because it's just a matter of horsepower at that point, or we can go down if we need to. But for a typical European lift, if you're familiar with that size, that's the lifts that we're installing right now.
Okay. All right. So you mentioned the idea of being able to pull cabs in and out of circulation, which is something I had not thought about, even in reading some of the articles and stuff that you guys have produced. And I think that's a really interesting concept. My question, though, is how fast could that happen? I'm thinking like maybe it's 10 or 11, like you said, during coffee break time, and you're only anticipating a few people riding the elevator, but for some reason a large group comes in. Could you get a bunch of cabs into circulation rather quickly, or is there some sort of delay?
So every time, and think of this cyclic elevator. So the shaft in a one shaft is always moving up, one shaft, the adjacent shaft is always moving down. So we're transitioning cabs, so to speak, at the top of the shaft and at the bottom of the shaft. So we're doing that in normal course of business. So the idea behind it is we can, as the elevator or the cab transitions from that down mode horizontally to go back to the up shaft, we're looking at a delay of, say, 15, 20 seconds, and even on the long side, say, 30 seconds to transition it. So the timing involved in moving these lifts or these cabs in and out of the shaft is very, from a time perspective, very efficient. I think the second part of this mobility, this urban mobility evolution, is the idea of big data and digitization. What I mean by that is, so we're being efficient in how we move people. Electronically, it's about sensing and identifying loads in cabs and loads in lobbies and in any area where somebody would board an elevator. So as we become smarter and smarter with technology, we are now able to sense, for say that the UPS person with a cart of boxes, and we've all been in that situation where the elevator stops and there's no room to get on because of whether it's baggage, whether it's cargo, et cetera.
Right.
So as we are learning about and understanding this communication with sensors in the lobby and inside the elevators, we could now understand when we don't want an elevator to stop at a certain floor because it has too much volume in it. In the past, we've always looked at weight. If it exceeded or came close to the weight limit of the cab, we wouldn't let it answer a call. And now we're getting smarter with looking at the volume inside the cab and saying, although we are way underweight on this cab, the volume exceeds any additional passengers to be added to it. So we could bypass that. And if you start looking at or thinking about that efficiency, when that elevator stops, the doors open, the doors close, then you have to wait till the elevator passes and repress the button.
Yeah.
That's all tied up in, say, 15 or 20 seconds. By having that intelligence, we could now bypass that and dispatch an elevator wherever we need it to go based on the loads. So I wouldn't be concerned with how much time to move the cabs in and out of the shaft. I think that's a great question. However, we would compensate that with the available technology that you're seeing with self-driving cars, with automatically detecting passengers. That technology is coming to the elevator industry, so we could start being smarter on when an elevator stops, when we may need to put an elevator into the shaft, when we may need to pull it out. So we're being more intelligent with the dispatching versus being responsive.
So do you see this all happening automatically? Is some computer monitoring the whole process, or is there, in some buildings, would it be required somebody to actually, maybe they have a bunch of sensors and everything that they're looking at, but an actual human is making the decision?
So the idea behind this, and our controllers are getting smarter. Our controllers in the elevator industry are self-learning, meaning that it starts identifying that at certain times my elevator should park on the lobby floor. At other times it should park on, say, the 16th floor, because we know that at this time a class or people are always exiting. So
that's really cool.
We're getting some intelligence, and that's just going to be enhanced by the rate of technology and how fast technology is moving. So the idea is that we don't want people to be manually entering or pulling cabs out of the system. It would be all electronically driven. And with that, although some people may be concerned with machines watching things, but we're seeing the same thing with computers being able to fly, land, and in the airplane, kind of control the entire system. So elevators are really getting close to that level of competency.
That's cool. That sounds really exciting. I like that idea of the elevator anticipating my needs. And if I'm always, going outside at this time of day, then I want the elevator waiting for me. It sounds perfect.
Right. It makes your path to your destination faster. Mm-hmm. And there's no reason why we can't anticipate those things, especially if you have a smart device on yourself or a badge to badge in and out of a building. It should already know that you work on the 16th floor, or you always go get a coffee at 10 a.m.
Yep, exactly.
It's just understanding those things without being too big brother-ish.
Right. Yeah. Okay, so that's great. There's definitely clearly a lot of benefits to this technology. One thing we haven't really talked about, though, that I'm aware of is that these systems can be a lot more energy efficient. Isn't that correct? Because the motors, they don't require such a huge motor and everything?
Yeah, so the idea behind the more efficient shaft size and the cab size is that we could, and power is completely directly proportional to how much work it has to do. So how much weight does it have to lift, et cetera. So when we start talking about linear motors, it is not as energy efficient as a typical elevator system. And let me explain why.
Okay.
From a power consumption standpoint, it's as efficient as a elevator motor. However, a cabled elevator car has a counterweight. So the motor is designed about half the size that it needs to be because you have, say, a 4,000-pound load. We're counterweighting it with 2,000 pounds. So in essence, we're trying to only move 2,000 pounds.
Uh-huh.
Now, with that said, that energy consumption starts to change radically as you start getting taller in a building. So we're moving a cab with a independent linear motor or magnetic motor up and down a shaft. So that initial energy to move a person is quite efficient. However, as I mentioned, when we're comparing it to a counterweighted elevator, it's already that counterweighted elevator, we're moving less weight, so that in itself is more efficient. However, when you start getting into that 30-story, 20-story, 30-story, 40-story, that weight now on that conventional elevator, that roped elevator, now you're moving so much mass because of the cables and the counterweights and the traveling cable that now we start seeing where the multi or the magnetic lift now becomes much more efficient in those areas. There's a component of actually moving mass, and there is a sweet spot, so to speak, for every elevator system.
Okay.
And the multi becomes much more energy efficient the higher we get. Now, with that being said, we are also, one thing we haven't started looking at because we're waiting for the test tower is when we start moving cabs in and out, now all of a sudden can we pick up energy efficiency by basically being more intelligent with how many elevators we have moving. Right now, with the elevator dispatching system, we only have a certain amount of capabilities, and that's why we started looking at other technologies like the twin, where we have two elevators moving in the same shaft, but they're roped, and now we're going to this next generation, or the future generation, where we have no ropes and no cables.
All right, great. So and talking with some other of my friends and colleagues about this interview I was going to do with you, the most common concern that people had was one over safety. My question for you is, what happens in the event of a power outage?
Great question. So elevators and Thyssenkrup actually decided that we will design everything to what's called a SIL 3 rating. And SIL, it's an acronym, S-I-L, stands for Safety Integrity Level.
Okay.
And so basically, it's a number of redundancies that are built into a system. So airplanes are typically running around a SIL 4. So they have enough redundancy built into the system that makes an airplane very, very safe. With the elevator system, we decided to go above and beyond and hit that SIL 3 rating. And so what that means is there's a magnetic tape running throughout the elevator shaft. So we're having the position of the cab basically encoded to less than a millimeter in positioning. So we know where the cab is at all times. We know the position of the cab in relation to the other cabs moving in the system, and we also understand which cabs are answering which calls, and do we need to slow down or speed up cabs to make sure that there's no worry about collision. With the power standpoint, if we have a power issue, typically the controllers are built with regenerative capability. So meaning that as we're using or consuming power for the elevator to go up, as the elevator cab is going down, we're braking. So very similar to a Prius.
Right.
We are actually trying to decelerate, and through that we're regenerating power. So we have an X amount of stored energy within the system that we could use to set the brakes, and then at the time of a complete power failure, there's methodology to also hold the position and set the brakes in place. So we call those elevator safeties, and basically it's a braking system on the vertical portion or horizontal portion of the shaft, very similar to, say, a modern-day car brake, where
so
you have pads
it's a mechanical brake.
Disc brakes. Yes, so there's braking systems electronically, and then there's mechanical brakes.
I see.
So there wouldn't be any fear of this thing just on a power outage, it just starts falling. That would be a bad thing.
Yeah, that's the concern that people had. All right.
Yes, and then the regenerative or residual power in the system allows us to then figure out where is the cab on a power outage in relation to a door opening, and depending on its position, we could move the cab based on that stored energy up or down to the next level, open up the cab doors, and evacuate the cab.
Oh, okay. Great. That's actually another question I had, so I'm glad you answered it. So you mentioned that you're building a test tower currently in Germany. That's nearing completion. Is that correct?
That is correct. So we began construction about a year ago, and it's right now on track to be completed December of 2016.
Okay.
So we needed to upgrade our test towers because of the higher speed elevators that we're now seeing in these ultra tall buildings that are being built, including the Freedom Tower in New York City and many of the other tall buildings in Dubai, Shanghai, etc. So this new test tower will allow us to test for high-speed elevators, elevators that are now starting to push 15, 18, 20 meters per second, and look at how do we effectively move people at those rates of speed. In addition to that, we will have a fully functioning multi-system in that test tower also, so that we can continue to further enhance the multi-system.
How fast can an elevator travel before it becomes uncomfortable to the passengers?
So in a vertical sense, we start seeing mechanical and human difficulty when we start approaching speeds of around 15 to 18 meters per second. And it's not necessarily the advent of the acceleration, because we can control that to make it feel like the person's not even moving, but it really gets to the point with how fast you're passing through different elevations and that pressure on the body.
Right, that's what I'm thinking, of the ears popping and everything.
So it's not So it's more of a comfort level for a person. We could accelerate and decelerate to the point where the passenger barely feels that movement. But it's like that airplane, your ears are popping, and that's the discomfort level that we start to get into. Now, there's ways around that. We can start looking at pressurized cabins, et cetera.
Wow.
But to answer your question, we start seeing a limitation around that 15 to 18 meters per second.
Okay. All right. So once this test tower is complete, you're obviously going to have a lot of experience that you run and everything, and you'll probably learn a lot more, I'm convinced. How long is it going to be until we actually see these in operation?
So the answer to that is more code-driven than technology-driven. The multi itself, from a technology standpoint, we could design and implement and engineer it to the certain whatever requirement we need to. The issue that we run into is we have several different sets of elevator codes and standards that we need to adhere to, and adhering to those standards aren't the biggest problem. It's getting acceptance from the governing bodies to accept this elevator system. So in actuality, we're probably on the very near side 2 to 3 years out before those we get the full acceptance on the multi-system. And we've seen the same thing happen with other new technologies. It's not a matter of, say, the elevator code for Europe is EN81, the elevator code for the U.S. is A17.1. It's not just a matter of getting that code body to say we accept the multi in the system. It's the delay really gets into then going to each jurisdiction, and in the U.S., say it could be city level, it could be county level, it could be state level, and working with and getting those codes then adopted into that state or county or city code.
Wow.
So there's a lot of paperwork that needs to occur, and that will always typically be a slower process than how fast we could engineer and technically develop a solution.
Okay. It's always the paperwork that's holding things up.
Yeah, unfortunately, but I think the key here is as we start getting and moving through those processes, we will, just like we did with the twin technology, we will go out and start selling and promoting it, because as you can imagine with the multi, the architectural community will have to understand and start designing the elevator shafts around the multi-system. It won't be a simple, well, I'll just replace my current design with the multi-design. Because the flexibility we start allowing the architects to have, the buildings owners we start to have, becomes much greater. So as soon as we get the nods on those codes that it's going to go through, we will go out and start actively selling it, and then work individually with certain developers to make sure that those codes are then adopted within that area of jurisdiction.
So you mentioned that you're currently designing for a European-size elevator. Do you see that as the first market where this will be adapted? We
have typically seen Europe and Asia adopt new technology faster than the Western world. So North America is typically slowest to adopt these types of technologies.
Interesting.
I don't have a crystal ball, but we've had the most success with looking at the Europe and Asia market, Dubai, for instance, and entering into those areas. And in a way, in several of those cities, it allows us to get them installed, and that helps the U.S. or North American codes look at, visit, touch and feel these installations, and that helps speed up our own integration.
Okay. And is this technology going to only be used in new construction, or is there any application where you could retrofit a building and install a new multi-system?
Great question. So the answer to that would be it could be used in both mod and in new construction.
Okay.
I think probably the sweet spot will be in new construction because most likely the areas that it's going to be installed and where you're going to see the maximum amount of benefit will be in super tall buildings. These high-rise buildings that are pushing, above 80 stories because of the efficiency of the system, not just from an energy standpoint, but moving people and then also giving back square footage to the building, I think is paramount. However, especially when we start looking at very mature markets such as North America and Europe, there's a lot of existing infrastructure that needs to somehow adapt and incorporate some of this new technology into it. So, things like the Hudson Yard project, say up in New York, where we're looking at how do we take an old section of town and revitalize it. That's where the multi would fit nicely. And as you mentioned, if you have a shaft, it's just a matter of pulling out the old systems and putting in the new. However, it's always more efficient to build new than modernize.
Mm-hmm.
And from a clarification, modernization in the elevator world is taking an old building and retrofitting it.
Okay. How disruptive do you think this technology is going to be to the current industry, just in regards to super tall structures? Is it going to, in maybe 10 years' time from now, do you think this technology will have completely replaced the old elevator system when it comes to new developments, or is there still going to be some 100-story buildings that are going to be built using the older rope technology?
In 10 years out, the multi-system is disruptive enough that it will change how we build buildings in the future. Because the multi now gives us flexibility, not just on tall buildings, where architects are now able to start structurally building extremely tall buildings, but it will also work extremely well in areas where it's been completely off limits to them. Designing a building structure that just doesn't move straight up and down. Now they could start looking at unique structures that are, say, integrated within the community. So we could start having interconnected buildings using the multi-system, where in the past that's always been, at least from an elevator standpoint, off limits to the architect. So in reality, the way I look at it is that now there are very little to no barriers to the point where if an architect can dream it, the technology, not only in construction but in the elevator business, is there that we could adapt and actually bring their dreams to reality. So as fast as the architectural community can embrace and start dreaming more is how fast we'll see the adoption of the technology. But it basically becomes limitless.
Okay. So I've seen some of the images that you guys have put out and everything I've seen is basically either you're moving straight vertical or straight horizontal, but you just gave me the impression that they could actually move diagonally. Is that correct?
Correct. So and this is why I call it disruptive, is whatever direction you want to move it, the system is designed, basically the carrying mechanism of the multi is, think of it as almost like a forklift, where you're able to rotate the cab in any direction, meaning that as you're moving horizontally or diagonally or vertically, we are now able to position that cab in reference to keeping it level regardless of what direction it runs in. So in essence, you could take like a Luxor in the casino in Las Vegas, where the elevators are running at a diagonal. Yes. And so now if you want to build a building that is, say interconnected, but it spans a highway, and the elevators work best because the building is situated diagonally, you can now design the elevator system for that.
Okay. And these cabins can move horizontally, but does it really make sense for them to be moving great distances horizontally? Wouldn't it be more effective just for somebody to walk?
That's it's all relative to distance. People will walk when they, especially if there's a aesthetically pleasing landscape or something that is enjoyable to walk, or it's fresh air. But they'll only walk a certain amount of distance before they start looking at different modes of technology. So, the reality of it, we have escalators, moving walkways, high-speed moving walkways. Our high-speed moving walkway uses the same linear motor technology as, or similar to the multi, where it allows people to move and accelerate to up to 3 times faster than a walking speed. So there's enough technologies out there that allows the designers some flexibility on the best way to move it. Personally, moving people horizontally adds a lot of additional issues, for instance, not necessarily from a mechanical standpoint, but moving people horizontally without allowing them to have a reference to dimensional movement becomes a little bit tricky. And think about it as if you're in a closed box and it started moving horizontally, that movement will cause your body to react. So there are some potential drawbacks to it, but it's just a matter of if a designer feels that this would be the best way to move people in a building, it's something that we could then take a look at and figure out how do we make it comfortable for the passengers.
Okay. And this system is in a loop. I'm imagining that you could actually have multiple circuits where, like, you mentioned to go up and then transfer to the right or left and then travel down. But could it also transfer to an entire different loop, for example? So maybe I'm in the bottom left-hand corner of a structure and I want to go to the top right-hand corner. Could it follow one track, transfer to another track, like maybe a switch in a train would do, and then continue all the way to the final destination?
Yeah, so earlier I had mentioned that we're doing this transfer at basically the top of the shaft and the bottom of the shaft.
Right.
That transfer could occur anywhere throughout this throughout the loop. So in essence, you could actually put a transfer wherever you wanted to. It could be on the basement level, it could be middle of the building, et cetera, where those elevators can then transfer to a different shaft. And that's where I think this is where it really becomes disruptive, is that if you have a large building and one side of it is convention center, you don't have to build excess space to handle that load. You could actually horizontally connect those shafts, and as, say, a convention is in progress or letting out, you could actually move elevators from one bank to another bank.
Okay.
So you're being much more efficient with the equipment that you're installing in buildings.
So if I'm understanding it correctly, I could take an elevator from the ground floor and it could start going up, and then depending on my final destination, it could either continue to go straight, it could transfer and go left and then go up again, or transfer and go right and go up, or et cetera.
That is correct, yes. There is no limit to how many transfer sections we could have, because as I mentioned, what's unique about the system is that the cab and the mechanism to attach it to the linear motors and that framework of that structure is cab dependent. So we're no longer dependent on what's in the shaft. The linear motors stay the same. However, the mechanism and the structure and the framework is all unique to that cab, so we could move those cabs anywhere we want within the building.
That sounds pretty interesting. Yeah, I mean, I definitely can see how this is going to give architects so many more options with the way that they build their buildings. Also, you kind of started to get into this.
We've been in buildings where, you take an express elevator up to, say, the 70th floor, and you have to transfer to another elevator, and it's always awkward. This now we're able to start looking at those perspectives and figure out what's the most efficient way to move people throughout a building or a structure.
Will this technology be used in tangent with the existing technology? I'm picturing a tall tower, and you mentioned that it becomes, the multi-system becomes more effective at greater heights. So would people be using a conventional elevator to get to the 20th floor still?
It's not a one and done type of arrangement when we start looking at elevator transportation. There is possibility to, make the entire building multi, but when we start looking at what we're actually doing with those elevators, it starts allowing us to look at different technologies. So, for instance, what we call back of the house, so the freight elevators or service elevators, these are typically very high capacity. Typically, they're not the prettiest. They have, curtains are all stainless steel cabs. So we still may have those service elevators that are conventionally built because it's the most efficient for the back of the house operations, but for the front of the house or for passenger movement, it may be all multi. So it may be a combination of traditional elevators, multi-elevators, and then also our twin elevators.
Okay.
Typically, one size does not fit all, and when we look at and help developers and designers, we typically look at what's the most efficient way from a space standpoint, from an energy standpoint, and from a technology standpoint to move people.
Okay. And this next question that I have, you kind of started to get into this, but it sounds like this technology is not only going to change the way we build buildings, but it could potentially also significantly change the way we build our cities. I'm thinking of this because you mentioned having a building and then transferring over a highway to another building. Do you see any significant implications that this technology will have on the construction of our cities in the future?
So excellent question. It's kind of peering into the future a little bit. But, the current design of existing infrastructure is really dependent on a horizontal plane. Mm-hmm. And we are already pushing the limits to that horizontal plane. So right now we move everybody on one plane, and we see congestion, we see difficulty in moving around in a city. I just read an article that I think McKinsey Global Institute put out, that the world's urban population will be grown by, I think, 65 million people per year, or basically around 180,000 people per day.
Wow. So
when we start looking at, and the U.S. is on the forefront, I should say the U.S. is around 75 to 80% of the population living in urban environments, city clusters. The rest of the world is around 60% of that population. So as people migrate and move into urban areas, and they're doing that for a number of reasons. One is convenience. They don't want to get in a car and drive 20 minutes to get to the grocery store or to play sports or to see a show, etc. They want that level of convenience within a urban environment or one city. So we're already seeing a change in the landscape, that now we're seeing communities, housing developments being built with their own school systems. We're now seeing a progression with even the next generation, where the residential communities are also built with office buildings, parks, recreation, etc. Mm-hmm. So as we see the urban environment or urban landscape start to evolve to this more compact structure, the ability to move people throughout that structure is always going to be increasing. And the conventional way with having cars, each individual driving a car, we're already seeing that level of congestion in multiple cities around the globe. So we need to start looking at better ways to move people. And we're seeing it with autonomous driving. We're seeing it with connecting metropolitan metro loops, train stations to bus stations, et cetera. And with the evolution of the city, having people, say, go down to the lobby, exit out the lobby door, and walk across the street to the next lobby and take the elevator up is almost a thing of the past, or at least should be starting to be considered a thing of the past. We should be able to connect buildings with other buildings at whatever level we need to, or that makes sense. So when we start looking at an urban structure where a park or recreational area is, say, on the 10th floor, there's no reason why that recreational area should be isolated to just one building. It should be interconnected with multiple buildings or with a cluster of buildings, and access to that should be a shared community experience. And I see, the buildings and the structures that are occurring is all about that interconnectivity, and that urban mobility and being able to move people very efficiently without the conventional ways of, say, traditional car ownership, et cetera. We're already seeing that migration happen. Younger people are wanting that independence, and so we start seeing car-sharing programs, things like Uber catching on, and we should see the same thing within inter-building movement. And now we have the flexibility to start looking at not just independent silos making up a city, but interconnected buildings that now share community spaces, community environments.
Yeah, that definitely makes a lot of sense. I mean, you just touched upon some of the key fundamentals to the vertical city concept itself, and I think you're right that it is the direction that the world is moving, and I would like to see it move that direction even faster, because it will solve a lot of our problems, like you mentioned, the congestion, and it just makes sense that if I want to go to the next tower over, that I should be able to do that without having to go all the way to the ground and then ride another elevator all the way back up.
That is correct. And I agree with you. We need to be, even from an environmental perspective, being more efficient with our resources. It just makes perfect sense not just to move people in between or interconnected with buildings, but also goods and services.
Yeah, totally.
Restaurants, transportation. You think about just delivering food or staples or sundry items to a building. We have a truck stopping at every single building. Why not be able to distribute goods and services from one location, having a distributed network, so to speak?
Yeah, that definitely makes sense. That's a really good, interesting thought you just gave me. They could stop at one location, ride the elevator up, and then distribute whatever it is they're delivering to the, say, 100th floor of multiple buildings, all without having to transfer back down to the ground level.
That's right. And, that we're no longer bound by the old rule of design. We can now start looking at, and what we call it in the business is first mile and last mile. And that first mile and last mile means that you could take a train into a city, but then people have to maybe walk for a half mile to get to their building. And same thing from their homes. They may have to walk a half mile or a mile to the train station, as an example. The same thing happens with the goods and services industry. That first and last mile, getting it to the building or getting it to a transportation network is always the biggest dilemma. And so with new technologies in urban mobility, and I'm not just talking about elevators, but we're talking about high-speed moving walkways, maybe it's high-speed conveyance systems, multi-systems. It starts now filling in that gap for that last mile, because we could start moving goods and services and people from those connected or distribution centers don't want to call a metro system a distribution center for people, but in essence, that's what it is. We can start moving those people very effectively, horizontally, vertically, diagonally, however we need to get them. So that's where I see that disruptive technology really come into play, is we could now really start looking at how does a city of the future get built that maximizes the efficiency for moving people, goods, and services throughout that cluster of buildings.
I think it's really an exciting time. I'm looking forward to seeing exactly how this technology becomes implemented. We just have a few minutes left here, so I want to give you the opportunity, if you have any final thoughts you would like to share, or perhaps a call to action that you'd like to make for the listeners.
I've talked a lot about in some of my beliefs on how future cities are going to basically be changed the landscape. I guess the call to action that I would like to at least deliver, or the message, is that conventional thinking, we're seeing that technology and the evolution of technology is happening so fast that we need to embrace and adopt these technologies faster. We've seen it happen in smartphone devices, but we're going to start seeing in the next 5 to 10 years an adoption of having driverless cars, et cetera. It's going to happen. And as we start looking at especially moving people within this, what I call last mile, getting people to move to different locations within a cluster of buildings, embracing that technology and even reaching out and providing some of those solutions. The idea of the next idea most likely won't come from businesses or companies. They will come from individuals having great ideas, great thoughts, and then getting that idea circulated into the community, and then actually being integrated into the design process. So, it's an interesting and fascinating time. It took 3 decades for the cathode tube or conventional TV to be eliminated, or close to being eliminated, and now we're seeing technology being replaced after a decade or even after 5 years. Yeah. And it's an incredibly exciting time. And I would ask any designers, architects that have ideas or questions on these last mile solutions to reach out to myself. I'll be more than happy to engage in those conversations, because as I mentioned, we may not necessarily have the perfect solution, but as we hear from people and understand their needs, technology should enable us to create that solution for them.
Excellent. And for all of our listeners who would like to get in contact with Brad, all of our notes and everything we've discussed in this podcast can be found by visiting verticalcity.org/podcast. I'll provide links both to the multi-system so you can learn more about it, and to Brad and to everything else that we've discussed. All right, well, Brad, thanks again. I definitely appreciate you coming onto the podcast. It was a really interesting interview.
Happy to do it. Happy to share some of the information about Thyssenkrup and multi, but more importantly, discussing urban mobility in the future of cities is always an interesting topic. So I appreciate you reaching out to myself and my company, and be more than happy to work with you on future initiatives.
Thank you. I appreciate that very much. Thank you for listening to this episode of Vertical City. Learn more about the Vertical City concept and continue the conversation by visiting our website, verticalcity.org. I truly hope that you have enjoyed this episode. If you did, please subscribe to our podcast, leave a review on iTunes, and most importantly, share Vertical City with your friends and colleagues so that together we can create solutions for sustainable living. I'm Lennon Richardson, signing off for the Vertical City team. See you next time.